to our fourth session about the RQ training. Lesson 4, site selection is today's topic. With me is Johannes. As in the lessons before, he will also take care about the training today. So we are all the participants are already arrived. So we start now the webinar. First of all, we go again. We do a little bit of housekeeping. While the webinar, please mute your microphone, switch off your cameras so we can reduce the used bandwidth so we have the best experience for all the participants. The webinar is planned for 15 minutes. We have a 10-minute Q&A on the end of the session. As usual, please post your questions inside the chat function of the meeting. The Q&A will be on the end of the session. We will moderate it. And if there are unanswered questions in the end of the webinar, at the end of the time, we will answer them via email to all the participants. So don't worry, if you have a question, we will answer it. And you're welcome to start now and join us for the meeting. I hand now over the presentation to Johannes. He will do the presentation. Johannes, you're up.
Okay, thank you. Well, hello everybody. Welcome back again to our lesson 4 on the RQ site selection. And I will give you some input and some general information about choosing the right measurement site for your RQ discharge measurement. And after that lesson, I will also give you a very brief introduction to the configuration of your RQ system, what are the main topics to consider, and how you are going to configure your instrument. But first, let's focus on the site selection. What is a good place where to install my RQ instrument? What do I have to consider when? So again, here's the content I want to talk about. Selection criteria. There is a list of things you have to consider about documentation, and I give you a pretty good list of examples where you could install, or what do you have to consider when installing an RQ system. So first of all, the site selection criteria. And the first one, when you come to a measurement site and you try to find out where do I put up my instrument, you look at the course of the river. You go up and down the river and look for a good place where to install your instrument. And the place should be a straight riverbed. So when looking up and downstream of the measurement spot, the river should be straight for at least 5 times the river width. So let's say if your river is 10 meters wide, then your river should be about 50 meters upstream and 50 meters downstream, pretty much or more or less straight. Of course, there are some restrictions for that. You probably have very few measurement sites where you get this framework, but if you're flexible, then you should consider, or you should comply with this rule 5 times up and down the river width. So you should have no curves in the river, keep it straight. You should have no secondary water inflow, depending on what you want to measure. But if you measure in the mainstream, you shouldn't have any secondary water inflow into the river. And of course, you should have as few obstacles as possible in your river. So here is an illustration about the rule about inflows. So if we have a channel here, a straight channel, a secondary inflow into the channel, you shouldn't put your instrument right here, but you go down about 5 to 10 times the river width and place your instrument here, or go up the river 5 to 10 times the river width and place your instrument here. Of course, it depends on what you want to measure. Do you want to measure the total flow, including the secondary flow, or do you want to measure the flow excluding the secondary flow? But in all cases, you should not place your instrument in this area here or close to this junction. Then when it comes to any obstacles within the river, so for example, if you have a river with an outflow, a little waterfall at the edge, so you should not place your instrument close to the outflow. But again, you go 5 to 10 times the channel width up the river and place your instrument upstream so that you don't have the influence of the outflowing water, where the water speeds up very much. The same is true for a vertical drop. So if you have a drop in the riverbed, you should not measure close to this drop, but you go up the river 5 to times the channel width, or you go down the river 5 to 10 times the channel width and place your instrument here or upstream of this position. And if you have any baffles or any big rocks or any other obstacle within the river, so don't measure in this area here. Again, go up the river or go down the river far enough that you don't get any influence from this obstacle or this baffle here. Then the next criteria is about the profile, the cross-section. Again, when you look at the river, or you have decided on the spot, or you have to make a first decision on your spot, then you should look at the riverbed, and the riverbed should be stable. So it should not change the cross-section within this spot. And it should be firm enough that it doesn't get affected by erosion or deposition of rocks on the way. And it should be free of big boulders, if that is possible, or any other obstacles. And there is one point to consider when you have a very shallow riverbed that can be critical, because a change in the water level of a very shallow river can change the cross-sectional area considerably. Here is an example for that consideration. So if you have a river that is about, in this case, 20-25 meters wide and pretty shallow, so it has water levels up to 1 or 2 meters. And considering a change here in the water level from 0.8 meters to a water level up to 1 meter, so from this level here, the lower blue line, to this level here, so you have a change of the cross-sectional area by roughly 5 square meters. So a very little increase in water level changes the cross area dramatically. So consider that when you have a very shallow river, that you need to have a good cross-section so that you can measure the water level precisely and the flow velocity. Then the water surface. For the velocity sensor to measure any velocity on the surface, you need to have some waves, and at least you should have waves that are about 3 millimeters high. Higher waves are good, but at least you should have some ripples on the surface to measure any velocity. And this also means that it can be difficult to measure velocity at very slow flow velocities. So you probably need about, or you can measure about 0.1 or 0.05 meters per second. And at this flow velocities, you might have very little waves. So that is what you have to consider. Then you should know what is the minimum and maximum water depth you experience at your site, and also the flow velocities. Consider a 100-year flooding event. So with this information, you can decide on which height and on which position you place the sensor and what type or what version of RQ instrument you're gonna need. Then I think for alpine rivers, you have to consider, or very small rivers in tubes or canals, you can have standing waves, and that can be problematic at high velocities and gives you less sensitivity of your velocity measurement. And in some cases, when the standing waves are extremely stable, then you can actually have erroneous measurements and you don't detect the correct velocity. Then you need to consider any external influences like constructions on bridge pillars. You have the basement of the bridge, and depending on the water level, these structures can have significant influence on your water flow. And also underwater constructions like dams or weirs that can distort your flow relation. And in very slow-moving rivers, wind can be problematic. So if the waves or the flow velocity is smaller than the wind speed, you can have waves on the river, and this can introduce false readings of your velocity sensor. Then you need to consider your installation options as well. So if you have a good looking site and you say that the river is straight, the river bed is stable, and we have a constant cross section, so it's perfect, you might not have the chance to install your instrument because you don't have any infrastructure to do so. So you have to consider, do I have an installation option? Do I have a bridge available, or can I build a cross arm that points over the river where I can install the RQ instrument? And last but not least, do you have power available at your site? Do you have mains power, or do you require solar power? So these are installation considerations you have to consider when selecting a measurement site. But then the point is as well, what is the mounting height of your sensor? So like you see in this illustration, depending on the installation height of your sensor, you have different measurement spots. So for example, if you place the sensor 1 meter above the water surface, your measurement spot is about 30 centimeters wide. And if you place the sensor 6 meters above the water surface, your measurement spot is going to be about 2 meters in diameter. So a very small river from a very high or a very large installation height, then the river might be smaller than the measurement spot, and this should not be the case. So make sure that your installation height matches the size of the river. And also on large rivers where you have a big water surface, installing the sensor higher up will get a better average of the flow velocity on the surface than when installing it at a very low installation height. But this very much depends on the available structures and on the available location you have to install your sensor. Then, once you have decided which measurement spot you're going to use, you have a nice stream with a straight river flow, and you have a bridge where you can install your sensor, and all the rules are more or less fulfilled. Then you should document the site for the evaluation. So take the pictures and take some videos of the measurement site. Maybe take a video of the water flow upstream and downstream, and of the water surface and the edge of the river, so you can see any obstacle that is on the surface. And also take some pictures from the side of the river, looking at the measurement spot where you install your RQ instrument. This will help us finding any difficulties when you have false readings, or if your discharge measurements should not match any comparison measurement, then it might be due to any obstacles or different flow regions of the river. Then also take a map of the monitoring site, so you can see maybe in Google Maps how the course of the river is and how the edges of the river look like. Then estimate the flow velocity, and this helps for configuring the instrument. And then of course we need a profile of the riverbed to construct your discharge table in the Q command. And if you have, it is always nice to have reference measurements like the tracer measurement or anything else to compare your new measurements you're going to gain with the RQ instrument. Okay, here so much about the theoretical considerations and rules. And here are actually a lot of examples I'm going to show you about RQ 30 measurement sites and what is good and what is problematic on these sites, to give you an idea when you assess your own site to look at. So here we have a small river in a subalpine region with a clear water river flowing below a bridge. Here it makes a bend. Here you can see on the bridge the RQ instrument installed with the velocity sensor looking on this side. So what can be problematic here is that you have a pretty low water depth, and the rocks in the river also already could have an influence at very low water levels. Then you have the bridge that might change the flow depending on the water level. So you have a change here in cross section from low water levels to high water levels. And you have a problem of the snow here along the edge of the river. So the snow can slide into the river and temporarily change change the course of the river, or even block the readings of the instrument. And we also have a very meandering or curvy flow of the river downstream. So when we install the instrument here, it should not look downstream, but looking upstream is a nice option, which shouldn't pose any bigger difficulties. Then another alpine stream with a channel that usually does not have too much water flowing, but it can have flooding during the spring season. You can see here on top sort of a tripod with the RQ30 looking upstream, and you can see here that is the problems we encounter here is the low water depth. So the water level is just a little bit higher than the rock surface on the riverbed. And this also gives a very difficult calibration of the system. Then we have a waterfall here at the edge, and that speeds up our flow downstream. So looking again at the RQ sensor, it looks upstream, and the upstream position is required here. Looking downstream shouldn't be done because you have all the difficulties with the water flow, the waterfall and the low water flow. Then another example of an alpine river in Switzerland. You have a river which has a large but still a bend here, a bridge over it, and the IQ30 would be installed on this bridge here in the center. Problem here is the boulders we have in the river. So consider where you place your instrument so that you don't look at one of these boulders here in the river. And because of the bend we're having here, downstream is not the best option. You can do it, but in this case, better would be if you install the RQ sensor looking upstream, where you have a good water surface and no influence of this bend here. Then another example of a channel of a power plant. You have a water drop here downstream, and the sensor installed on a cross arm on top here, looking upstream. So what is nice here at the site? It's a very straight river. So this is a very good part. We have the waterfall that speeds up the water. So downstream, in this case, wouldn't be the best choice, except if you would move the sensor further up the river. But looking upstream is good. So either if you have the instrument installed here, it should look upstream, or if it has to look downstream, then you should move the cross arm further upstream so that you get away from the waterfall here. Then an example of another alpine river that flows through a village. We can see here that we have a lot of deposits from floods and even some little islands that are forming at a very low water level. So this might be problematic. So you don't exactly know where you should install your RQ sensor. Another thing is the bridge itself. If the water level rises and the cross-sectional profile changes due to the base of the bridge here, that makes the cross-section smaller at higher water levels. So this is drawback of the site. The islands are forming at low water levels, the deposit of gravel, and the bridge base. But the river is straight, and we can install the instrument either upstream or downstream. This is nice in this case. Here is a close-up of the sensor of this bridge. It's mounted underneath the bridge here, and you can see the sensor is looking here downstream of the river in the center. Yeah, excuse me, I'm just going to do a minute technical break. We have just a little issue here. I'll be back in a second. Okay. Yes, I'm back again. We had, I think, a little sound issue here, and I hope it is now better for you, that you can hear me more clearly than before. I will continue from here on to the next example slide. So here we have a technical channel that is built for the base tunnel that is currently being constructed at the Brenner in Austria. So you can see here a basin of water that is collected in the tunnel walls, and you can see the sensor here mounted on a cross arm on the river, looking downstream. What is good here on this side, we have a straight river. That is the good thing about this side. But we have this waterfall here that speeds up the water. And we have a change in cross section from the basin here to the river. So looking upstream here is no good choice at all, because we have a dramatic change of the flow velocity from almost standing water here to high velocities here. And looking downstream is not ideal, but the better option in this case. So space is very limited in this case, and it's difficult to make a decision how to install the instrument, looking upstream or downstream. And such situations might be quite common, that you should stick to certain rules, but you can't because the location is very much restricted. So you need to find the best option that is possible for such a location. Then we have a nice stream in Germany that has the problem. It is this very slow moving water. So any crosswinds you might have here could produce any waves that don't represent the flow velocity. And you can see it's very green. This will also continue in the river, so you might have a lot of vegetation growing at the riverbed, and this might even further slow down the flow velocity of the river. So this is the limitation you have here on this side, the slow flow velocity, that you have enough waves to do your measurements. But in this situation, it's still okay. So looking downstream or upstream, both directions are well for this measurement site. Then you have here the opposite. You have a river with extreme turbulence, with standing waves here and here and here, and it's a very difficult site to get accurate flow measurements, but still possible with the RQ30 installed up here. And looking downstream or upstream is not a big issue here on this side. It's more the big standing waves and the white water that limits the accuracy of your discharge measurements. Then another artificial channel here in Austria. That's a perfect site. You have a straight river. You have a cross section that is stable upstream and downstream, so it doesn't change at all. So you have a constant flow upstream and downstream. It doesn't matter, you can install it in both ways. Then a similar installation at an artificial channel where the RQ instrument is installed underneath the bridge. This has the advantage that it's protected from rain and protected from vandalism, but on the other hand, the specific structure of this bridge into T shape here this can lead to reflections of your radar signal and produce some secondary velocity readings, especially when the water level, the water surface is very smooth here and we don't have much waves that can be detected. So this is problematic at the site, the very slow velocity, and maybe also the structure of the bridge here. But looking downstream or upstream is those considered here for this site. So go that way. And then here another river in Malaysia. You can see that here the RQ30 was installed on a cross arm looking out to the river. Here you just have to pay attention that you don't get too close to those boulders here. So the sensors should look somewhere here onto this area, away from the edge of the river and away from those boulders. And then looking upstream or downstream doesn't matter in this case. So the waves are good, it's no white water and it's no extremely slow moving water, so this is absolutely fine. And then here another nice stream in Austria with a straight river that has a good cross section, so it doesn't change here on this side. But you can see here, looking upstream, at the back of the bridge, you have an installation or a construction that protrudes into the river. So you should not install the sensor looking upstream, but downstream here is very nice and fine and a choice for this site. And then here, Alpine River in Switzerland with an RQ instrument mounted on a bridge with a solar panel for powering. It's a good site where you can look both downstream and upstream. What might be difficult is the standing waves that can form here at higher water levels. And so it might also be difficult to get the accurate water level of this river. And here an example of a channel, an irrigation channel in Africa. You have here the RQ installed on a cross arm onto the river. And you can also see that it's a very shallow river, and you have a dramatic change here in the cross section. So the cross section downstream is totally different from the cross section upstream. So downstream you have this construction here, and upstream you just have the sandy river bank. So in this case, looking upstream would be the choice, and downstream you have this this narrowing of the river, and as soon as the water level rises above this edge here, then you have a totally different water flow regime than looking upwards. Here an example of an RQ instrument on a cableway in the river. This is a rather difficult measurement site. You have this mountain river with all those rocks and little waterfalls and changing flow speeds. So this is not a site where you, not an ideal site for discharge measurement, but it can be done and it gives you an indication of the changing discharges. So you have to select a good spot here, and then it's okay to look downstream or upstream. But again, the site is difficult with all the rocks and also at this low water level here. Here an example from Georgia, another mountain river with the RQ instrument installed on a wooden bridge. And The problem here is the changing flow speed. You have a rock or tree here and rocks upstream that change your flow velocity, and the distance to these obstacles here is probably not big enough. So it's not ideal, but we have a bridge at this site and no other option to install it, so this is the choice where we install it. But again, you need to look downstream. Upstream would be too difficult with those limitations of the rocks and flow speed here. And here another example of a very good, a very easy site straight canal with a constant cross section. So you can install the instrument on this bridge downstream or upstream, and you will get good results. Here another mountain river in Austria. The problem here, we have a changing cross section. Here upstream we have a wide riverbed, and then when the bridge was constructed, the river narrows and we have this sort of channel here. But if we mount the instrument underneath the bridge here, we can either look downstream or upstream as long as we're in this section with the constant cross section here. This is an example of where the instrument is mounted. Look here, where the instrument is mounted right underneath the bridge and attached to the wooden planks of the bridge. And here it looks upstream of this bridge. Here also a rather good site of an alpine river. Looking downstream or upstream is fine. Here, maybe it's better on the downstream side as it is installed here on the bridge. What the bigger problem is some standing waves here and some rocks further upstream. But otherwise, the site is quite nice. So here's some a little summary of good conditions for a measurement site. Here at the Rhine River during flood conditions, we have a strong flow, we have good waves, and we have little wind influence. We have a straight river and a stable river bed. And here also a natural river. We have a good installation site, a straight river, and a stable river bed, and forming good waves here on the surface. And also this technical channel here, we have a very constant profile, which is constructed here with rocks on the bottom and on the walls. We have a bridge to install the instrument, and we have a good waves due to the stony river bed. On the other hand, here are some sites with limitations. For example, this irrigation channel here. It has a very slow water flow and therefore very little waves. And here also the wind can have a big influence due to the slow flow velocity. Also this natural river here with a very low flow velocity, no wind, no waves, and the wind can have a significant influence. And also on this natural river, big river, here it's a very wide river, very open, so wind definitely has an influence, and especially on very slow flow conditions, the crosswind might make it very difficult to get accurate readings here. Okay, so much about the site selection criteria. I will give you now another introduction to
Johannes, just a second, please.
Great. Yeah.
Thank you very much for this